All right. Question 13 says, on the graph below, point A, which is 3, 4, and B, C, with coordinates 4, 3, and 2, 1 are graphed. What are the coordinates of B prime and C prime after line segment BC undergoes a dilation centered at point A with a scale factor of 2? Okay, so what you have to do first, and this is kind of a tricky question, what you have to understand is you have to draw two rays from point A, passing through point B and passing through point C, okay? And I'll just put this on the side here. You had to draw two rays. Hold on one second. Oh, my apologies. Keeps switching here. So you have to draw two rays and then calculate the slope of each ray. And you will see that once you calculate the slope, then you have to use the dilation with a scale factor of 2 to determine those points. So the slope of ray A to the end of this point, I don't know what that is. We could call it C if we want, D if we wanted to. But the slope of this ray that you see here is down one and to the right one. Now, if we go down one and to the right one more time, this point will be the point B prime. Now, this ray over here, this is down 3 to the left 1. Go down 3 to the left one more time, and you will see that this is now C prime. This, ladies and gentlemen, is your dilated line by a scale factor of 2. So from here to here, this line is a dilation of 2. It shows a dilation of 2. So if we're looking at the points, point B prime is 0, let's see, 1, 2, 3, 4, 5, up 2. So B prime is the point 5, 2, and C prime is the point 1, -2. So the answer for this one is going to be choice 1. That was definitely a trickier question, but you had to draw those rays or else you didn't know what to do. Number 14, in the diagram of right triangle ADE below, BC is parallel to DE. Remember what I keep saying. They tell you that these are parallel because they want you to conclude that triangle ADE is similar to triangle ABC by angle. Because these are right angles and A is reflexive. Now, which ratio is always equivalent to the sine of A? Well, the sine of anything, you should know that the sine of anything is equal to the opposite over the hypotenuse, and that's based off of your knowledge of SOHCAHTOA. Now, the opposite of angle A for the smaller triangles BC over AB. So the sine of A could equal BC over AB, or it could equal the bigger triangle, which is going to be DE over AD. So it could be any one of these two. And if we look at our answer choices, the only one that would work would probably be choice 3, because BC and AB, that shows opposite over the hypotenuse.
Number 15. In circle O, secants ADB and AEC are drawn from external point A, such that points D, B, E, and C are on circle O. If AD equals 8, AE equals 6, and EC is 12 more than BD, the length of BD is what? Okay, so I don't know if you guys are realizing this, but right at the beginning it says in circle O. I'm not seeing circle O, so our first step is to draw this diagram. So the first thing I'm going to do is just draw my circle. And I notice here I have this vocab word secants. I know that there's going to be two secants. There's going to be ADB and there's going to be AEC. Now, a secant is just like a chord, only it goes through the circle. So I'm going to have one secant here, and then I have a second secant underneath. And I know that it's telling me that they're drawn to an external point. External means outside. So I know this outside point would be A. All right. I know that my first secant is ADB, so I'm going to label that ADB. And my next one is AEC, so I have A, underneath is E, and then C. All right, so that's just getting the picture drawn. And now I'm going to label the other information that they told me. So I know that AD is 8. So I'm going to put an 8 out here. I know that AE is 6. Let me label this with a 6. And then the harder part, it says that EC is 12 more than BD. Well, right now I don't know what DB is, so I'm going to label that with an X. All right. So I know that EC is going to equal 12 more, so that's going to be 12 plus, 12 more than BD. So right now, if I'm making BD X, let me go ahead and label that on my diagram. So I know that BD, wrong color, BD is X. Then I know that EC is going to be 12 plus X. So let me label that underneath, 12 plus X. All right. And now if I want to solve for any of these missing pieces, this is one of those formulas that just has to be memorized. It's not anywhere on the reference sheet. Guys, I don't know if you're seeing it, but it's your outside hole. So let's go ahead and write that down. I know it's going to be my outside hole equals my outside hole. All right. So if I look at the secant up top, ADB, I can see that the outside section is 8. So I'm going to fill that in. So it's going to be 8 times the entire line segment. So 8 plus X is just going to be 8 plus X, right? Those don't combine. And now I'm done with the left-hand side, moving on to the right-hand side. So again, now I'm going to look at the bottom secant. So my outside piece is 6, so I'm going to fill that in. So it's 6 times the whole chunk. So if I look at this entire piece, well, 6 and 12, when I add those together, make 18. So it's really going to be 18 plus X, because I know 18 and X are not like terms. They can't go together. And now I'm going to go ahead and distribute so that I can solve this question. So I'm going to distribute 8 to 8 plus X. So I get 8 times 8 is 64 plus 8 times X is 8X equals, I'm going to do the same thing on the other side. I'm going to distribute. I know that 6 times 18 is 108. And I know that 6 times X is just 6X. All right, now I'm going to go ahead and just continue solving this. I'm going to start combining like terms. I'm going to move my X's together first. So I'm going to bring my smaller to my larger. So I'm going to subtract 6X on both sides. Those cancel. So now I'm left with 64 plus 2X equals, I bring down my 108. And now that I've combined my X's, I'm going to go ahead and combine my numbers. So I'm going to bring my smaller to my bigger. I'm going to subtract 64 on both sides. So all I have left is 2X equals 44. And then the very last step, I have to divide both sides by 2 so that I can isolate X. I can get it by itself. And I can see that X equals 22 as my final answer. It's so important that you always reread the question. So it's asking me what's the length of BD. So let me go back and double check. BD is just represented by X. So X is 22. My answer is 22, choice 2.
A parallelogram is always a rectangle if it's what? So we're looking for the property that is specific to the rectangle. Okay? We're not looking for vagueness. We're looking for specificity. So choice 1 shows that the diagonals are congruent. Does that prove a rectangle? You bet it does. Choice 1's the answer. Diagonals bisect each other? No, that is a parallelogram. That is way too vague. Diagonals intersect at right angles. Diagonals intersect at right angles. No, that's a rhombus. That means that the diagonals are perpendicular. And the opposite angles are congruent? No, that is a parallelogram. So it has to be choice 1. Diagonals are congruent.
Number 17. Which rotation about its center will carry a regular decagon onto itself? So there's 2 important vocab words here, rotation and decagon. All right, so if I'm wanting to rotate a decagon, the first thing that I'm thinking of is that a decagon has 10 sides. All right, so if I want to figure out how many degrees are in each turn, because I can turn that decagon 10 times, the formula that I should be thinking of is 360 degrees divided by the number of sides is going to equal the angle of rotation. All right, so again, if I have a decagon and it's 10 sides, I can keep turning it, right? I can turn it 10 times. But the question wants to know how many degrees are going to be in each turn. All right, so again, this is the formula that you want to follow. So I'm going to take my 360 degrees and I'm going to divide it by 10 because a decagon has 10 sides and I get 36. All right, you guys are probably thinking, yikes, there is no 36 as an answer. But don't worry, because there's only 36 degrees in the first turn. How many times can I turn it? 10 times. So I'm going to start listing out the degree measures in each turn. So if I turn it 1 time, that's 36 degrees. If I turn it 2 times, that's 72 degrees. Okay, I'm just adding 36 to get to my next turn. All right, but again, I don't see 72, so I have to keep going. If I add on another 36, I get 108. But again, I'm not seeing that answer, so I have to keep going. Then I get 144. Okay, I'm not seeing that. I get 180. Okay, I'm not seeing that either. Then I get 216. Okay, I'm not seeing that either. But when I add it one more time, I get 252 degrees. And I can see that that is a choice. It's going to be choice 4.
Question 18. The equation of the circle is x squared plus y squared minus 6y plus 1 equals 0. What are the coordinates of the center and the length of the radius of the circle? So we need to use completing the square. And in completing the square, we keep your letters on one side, numbers on the other side. So we are going to move this 1 over. So we get x squared plus y squared minus 6y is equal to negative 1. So x squared plus y squared minus 6y plus something is equal to negative 1 plus something. In order to get this number in here, we need to use the formula b divided by 2 squared to get that number. Remember, we're trying to create a perfect square trinomial. So we take half the linear term, in this case is going to be negative 6. We take half the linear term and we square it. Negative 6 divided by 2 is negative 3. Negative 3 squared is going to be 9 and 9. Now, this is factorable by the AM method. What adds to negative 6 and multiplies to give you positive 9? Well, that's going to be y minus 3, y minus 3. And that x squared, by the way, carries along for the ride down here, is equal to 8. Let's keep going. Y minus 3 and y minus 3 can be written as y minus 3 squared is equal to 8. So the center is 0, 3 because it's its opposite, and your radius is the square root of 8. Now, the square root of 8 can be broken down into a simplified radical by taking the square root of 8 into 4 and 2, because 4 times 2 is 8. The square root of 4 is a perfect square, so that is going to be 2. Radical 2 carries along for the ride. So your center is 0, 3, and your radius is 2 radical 2. The answer to that is going to be choice 1. Your center is 0, 3, and your radius is 2 radical 2.
Here is number 19. It says a parallelogram ABCD has coordinates A, 0, 7, and C, 2, 1. Which statement would prove that ABCD is a rhombus? So let's start out with this whole point that figures are all named in the order of their vertices. So if A is here, then B is going to be over here, C would be down here, and then D would be over here. So just to give you an idea, so when they give you the coordinates of A and C, we know that A and C have to be one of the diagonals. So the first thing I highly recommend is using some graph paper. So we're going to do here, since they didn't give us the X and Y axes, we're going to draw that. This is our x-axis, this is our y-axis. So A is at 0 on the x-axis and 7 on the y-axis. So 0 on the x and 1, 2, 3, 4, 5, 6, 7. That's going to be where A is, 0, 7. And C is at 2 on the x-axis, 1 on the y-axis. So over 2 and then up 1. So that's going to be where C is, 2, 1. So it says, which statement would prove that ABCD is a rhombus? So I always ask myself, what did they give me and what do I know? They gave me a diagonal, right? A and C, when we connect those, again, you're going to see that that forms one of the diagonals. So B is somewhere over here, D is somewhere over here. So what do we know about the diagonals? The diagonals of a rhombus are perpendicular. Okay, so here's the symbol for perpendicular. So what do we know about perpendicular lines? They have negative reciprocal slopes. So if I can find the slope of AC, which is up 1, so remember slope is the change in y over change in x. So we're going to start at C. I'm going to go up 1, 2, 3, 4, 5, 6 units on the y-axis. And then from there, I'm going 1, negative 2 units on the x-axis. When we reduce that, that comes out to be 3 over negative 1. So I know that the slope of this diagonal is going to be up 3, negative 1, up 3, negative 1, which means that the slope of line segment BD, the other diagonal, so line segment BD, I know that the slope is going to be the negative reciprocal, which is going to be, instead of negative, positive, and then reciprocal means to flip the fraction. So 1 over 3. So therefore, the answer to this question is going to be choice 3. So if we look at the other answers, the slope of line segment AB is 1 over 3, and we just said that the slope, that is not correct. So AB is not, well, we don't know. It's not necessarily 1 over 3, and it probably isn't according to this picture. The length of BD, so that would be the length of this diagonal, is the square root of 40. I don't actually know if that's necessarily true. I know I can find the length of the segment AC. So segment AC, again, if we make that right triangle, it's up 6 over 2, so 6, 2, and then if we find the length of that diagonal, so 6 squared plus 2 squared equals AC squared. 6 squared is 36, 2 squared is 4, that's equal to AC squared. 36 plus 4, that's 40, equals AC squared. The opposite of squaring is square rooting. So I know for a fact that the length of AC is square root of 40. Which is not necessarily the length of segment BD, and in a rhombus, they're not going to be the same length. Now, the midpoint is going to be half of the slope, so if we start at C and we go up 3 over 1, okay, that's going to be the midpoint of this line segment, which is at 1, 1, 2, 3, 4, but that doesn't prove that that's a rhombus. So the only way to prove that it's a rhombus is we know that the diagonals are perpendicular. So let's look at example number 20. It says point C is on line segment MN such that MN is to QN is equal to 2 to 3. So if M has coordinates of 3, 5, and N has coordinates of 8, negative 5, what are the coordinates of Q? So again, the thing that I'm going to do is I'm going to graph this, because that's the easiest way to do this. So I'm going to take my graph paper. And M is at, again, x, y. So it's over 3 units on the x-axis, and this is my y-axis. So over 3, 1, 2, 3, 4, 5, that's coordinates of M. And N has coordinates of 8 on the x-axis, negative 5 on the y. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. I'm just going to move this up here. So the coordinates of M, we said were at 3, 5, and then the coordinates of N, which is right here, is at 8, negative 5. So in order to divide a segment proportionally, what we're going to do is we're going to find the slope of this line segment. So once again, the slope of any line is the change in y over change in x. So I'm going to start at N, and I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're going to make that right triangle. So 10 units on the y-axis. And then from that point, 1, 2, 3, 4, negative 5 units on the x-axis. So that's step 1. Step 1 is to find your slope. Then step 2 is you're going to divide the slope by the total number of parts that you want your segment to be divided into. total parts. Sorry about that. Total parts. So if we take this, we want 2 parts to be closest to MQ, and we want QN to have 3 parts. So 2 plus 3, that's a total of 5 parts. So we're going to divide by 5. So 10 divided by 5 is 2. Negative 5 divided by 5 is negative 1. So now we're going to start at N, and we're going to follow that new slope. So we're going to go up 2 over 1. And if you don't end up back on your line, then that's how you know you made a mistake. Up 2, negative 1. Up 2, negative 1. Up 2, negative 1. Up 2, negative 1. We're back to point M. So now you can see we have 1, 2, 3, 4, 5 total parts. So in order to find Q, we want from M, we want 2 parts, right? So 1 part, 2 parts to be MQ. And then from Q to N, we're going to have 1, 2, 3 parts. So that means Q is going to be this point right here. So we'll start at the origin and we go over 1, 2, 3, 4, over 5, up 1. So the coordinates of Q are going to be at 5 units on the x-axis, 1 unit on the y-axis. So your answer is choice 1.
In the diagram below of circle O, GO is 8, and the measure of angle GOJ is 60 degrees. What is the area in terms of pi of the shaded region? Okay, by now you should know that the area of a sector is n over 360 pi r squared. Okay, however, you need to find this angle measure because it's asking you for the shaded region. I guess someone decided to remove just one slice of the pizza and now they want to calculate the area of the whole thing. So there are 360 degrees in a circle. This blue angle is going to be 300 degrees. Sorry, I just said the answer. I apologize. 300 degrees. It's 360 degrees minus 60, which is what's given here, and that equals 300. So the area of the sector is 300 over 360 pi times the radius of 8, and you square it. Let's plug in 300 over 360 and 8 squared. 300 over 360 times 8 squared. Why am I not plugging in a pi? Well, because if you look back at your answers, everything is in terms of pi. So I'm going to go ahead and press enter, and we get 160 over 3. So your area is 160 over 3, and then just attach on the pi at the very end. So your answer is going to be choice 4.
Here is number 22. A circle whose center is the origin. So origin, that means that the center is going to be at 0, 0. Passes through the point negative 5, 12, which is x, y, which means the distance between the origin and this point is going to represent a radius. Which point also lies on the circle? So the easiest way to do this is to actually graph this. So let's just give you an idea of what's going to happen. All right, so we're going to have the circle whose center is at the origin. So we can call that O. And then this point is going to be at negative 5, 12. So just think about that. A circle, then we're going to use our compass. A circle is all the points along the circle, right? So any point from the center to any point on the circle, that's considered a radius. Okay, so what we're going to, there's a couple of different ways you can do this one, but the easiest way is to just be visual. So we're going to take our graph paper and we're going to make a graph. So I'm going to draw an axis called the y-axis that goes north and south. And then I'm going to draw a horizontal axis that goes left and right. This is the x-axis. So here, like we talked about, is 0, 0. That's going to be our center. I'll call it 0, 0. Then there's this point at negative 5, 12. So from the origin, I go negative 5 on the x-axis. So 1, 2, 3, 4, 5. And then positive 12 on the y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here's the point negative 5, 12. So then I'm going to take my compass, which when you're sitting on the regions, that'll be supplied for you. And I'm going to open up my radius to this point here. And then I'm going to draw a circle. And now what I'm going to do is I'm going to plot all these points. Oops, what happened? For some reason that moved. Oopsie. You know what? I might have to redraw that for you. Oh, I think that'll work. Okay. So here, let me use my highlighter. I'm not sure what happened there. So this is the circle that we're going to use. So any point that's along this circle drawn from the center 0, 0 is going to be considered the radius. So I'm going to take our answer choices and let's graph. So it says which point is also on this circle. So which point is anywhere on that pink part that I draw. So I'm going to take the first point at positive 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, positive 3 on the y, which is this point here. Clearly that is not on the circle, so it cannot be choice 1. So let's look at choice 2. Choice 2 says negative 12, negative 13. So from the origin, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Negative 12, then it says positive 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Clearly that point is not on the circle. So now they give me 2 more choices with radicals in it. So it's 11. That's going to be 11 units along the x-axis. And then if you just use your calculator, you put in 2, the square root of 12, and that's going to give us an approximation. So 6.92. So this point is actually going to be, put this over here, 11 comma 6.92. So almost at 7. So let's see if this point is on our graph. So let's go back over here and let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 11, and then 1, 2, 3, 4, 5, 6, and almost 7. That actually looks like it's on the graph. So I think that it's this one, but let's check the last one just in case. This is at negative 8 on the x-axis, and then 5 radical 21. So once again, we're going to get a decimal value for that. So 5 times the square root of 21 gives me 22.9, so almost 23. So we're going to go negative 8 and then positive 22.9. Positive 22.9. I have a feeling that that's not even going to make sense. So 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and then almost 23. So as you can see, this is choice 1, clearly not on the graph. This was choice 2, clearly not on the circle. This was choice 3, clearly on the circle, and this is choice 4, clearly off. So this is pretty much process of elimination. You make your graph with the graph paper that is supplied to you, and then you can graph all those points, and then just make sure that you use the calculator to figure out your radical functions.
Question 23. A plane intersects a hexagonal prism. The plane is perpendicular to the base of the prism. Which two-dimensional figure is the cross-section of the plane intersecting the prism? So what you have to know is, well, what is a hexagonal prism? Well, to the best of my ability and drawing ability, the hexagonal prism is just a prism that has the bases that are hexagons, and it looks like this. All right. For some reason, I think of like fancy skyscrapers that look like this, like office buildings or something. All right. This is the hexagonal prism. So it says there's a plane. A plane is perpendicular to the base of the prism. Well, the base of the prism is down below here. That's the base of the. Well, these are technically both bases, but I like to consider the base, the bottom, and there's a slice that's going down the prism. Well, what is the cross-section of the plane intersecting the prism? Ladies and gentlemen, it is the face of the hexagonal prism. What figure is that? That's a rectangle. So therefore, it is going to be choice 4. Triangle, trapezoid, and hexagon make absolutely no sense. Hexagon, the cross-section would be a hexagon if the cross-section was horizontal, meaning parallel to its base. This is saying perpendicular to its base. So it has to be a rectangle. And the last question, 24. A water cup is in the shape of a cone and has a height of 4 inches and a maximum diameter of 3 inches. What is the volume of the water in the cup to the nearest tenth of a cubic inch when the cup is filled to half of its height? So what I'm going to do is I'm going to draw myself a cone. All right, and this is the water cup that you get at like the dentist's office, so, or the doctor's. So we get this shape here. Just one second, I'm going to straighten this out just a little bit. There we go. There's my cone. And it says here that it has a height of 4. So that has a height of 4. And it says that it has a maximum diameter of 3 inches. So therefore, your radius from one point to the end is going to be 1.5. That's your radius. Okay? So, and then it says here, what is the volume of the water in the cup to the nearest tenth of a cubic inch when the cup is filled to half of its height? So, to half of its height, that's right here. Now, we need to find the volume of this, ladies and gentlemen. We need to find the volume of this right here. So, the volume of that water level, we need to figure out, well, what's the height? The height is now 2 because it's filled to half of its height, and the radius is half of 1.5. The radius is I'm sorry, I just said 1 point. It's 0.75. That's the length of the radius of the smaller cone. So the volume of the water level, or the smaller cone, whichever how you want to think about it, is 1/3 pi r squared times the height. Okay? So that will become, the volume is equal to 1/3 pi. The radius is 0.75 squared times the height of 2. When you plug this into your calculator, you get 1/3 times pi times 0.75 squared times the height of 2, and you get 1.18, or 1.2, because it says round to the nearest tenth, right? Yes, 1.2. And that is the volume of the cone when it is filled halfway.